So we are now starting step 3 of workshop 4. So just looking at our worksheet again, it says to choose a section of the time series with no obvious gaps for further investigation. So we actually need to have a regularly sampled or continuously sampled time series. And we're going to try then subsampling it or changing the sampling rate and also the sampling length of this time series to see what the impact is on what periodic components that we can observe. We'll also need to have a regularly sampled time series in workshop 5 so that we can find the power spectrum. So let's choose a section of the time series with no obvious gaps then. If we go to our figure, wherever that is. Figure 1. Okay. So this is just where we finished at the end of step 2. We have our time series with the, I haven't bothered to put the axes labels on because we're not really keeping this. This is just for reference. So we can see that if we choose, say, the first 200 days, that looks like it's a pretty continuous time series. Visually, at the moment, there might be gaps, so we'll need to check for that. We want to avoid this big chunk here because it's not going to be very easy to fill in that gap there because it's quite large and we don't have any data to help guide us for that section. So we'll avoid that, and let's just choose between 0 and 200 because that's a nice even number. Okay. So if we want to choose a section of time with that's 200 days long, then we want our time axis to run from 0 to 200 days. And of course we have 96 samples per day, so that means that the number of data points in 200 days is the sampling rate, so 96 times 200 days. Okay, so if we try and assign, so let's, our time axis in days, we just want to choose the first 200 days of that, so let's just call that TD1, and we want that to go from the first sample to the sample which occurs at 200 days, which will be 200 times 96 samples per day. Okay, so the sampling rate Fs. Now that, oh, I forgot to put in the equals sign, and I already know this is going to give me an error anyway. Oh no, it worked. Great. So now we have the first 200, sorry, not first 200, the first 200 days, yes, the first 200 days of our time axis. And we should also do the same thing for our height, tidal height is equal. So H1 is equal to, oh, I know why this is not correct. I have made a mistake, sorry. So this should be TD1 is equal to TD. So we are taking a subsample or a truncated section of our time series, and we need to do that for both the time axis and the tidal height variable as well. Okay, so I already know this is the error I was expecting. There we go. And the reason why we have an error here, so you can see we are looking at our previous time axis, and we want 200 days worth of it. So we multiply it by the sampling 200 days times the number of samples per day, and that should give us the number of samples in 200 days. So that's where we want to finish. Now, why is that not working, one might ask? Well, if I just write down Fs and see what that number is, you can see that it's giving me 96.0000. And when you use a number as an index in an array, then it needs to be an integer. Okay, so what's happening here is that it's expecting this number here, 200 times fs, to be an integer, but because we've got decimal places after here, it's interpreting it as a non-integer. And what we could do quite simply is just to cut off any of the decimal places by using a function called floor. Okay, so if I go floor of fs, then it just gives me 96. I'll just to show you another example, say we do floor of 1.9, something like that. Okay, just gives me 1. If I go floor of 34 point, I don't know, random numbers, okay, it gives me 34. So that function, all it does is it just gets rid of all the decimal places and gives you the integer component. Okay, so if we go back and we now define our time axis for the first 200 days to be from 1 to 200 times the floor of our sampling rate. That works, so that's fine. And then we need to do the same thing for our tidal height. So h1 is equal to h, and then we want to choose the same sample points, so the same indices, so that they match up. Okay. So this is the time series that we're going to be working with, and let's just plot it, might as well, just to check that it looks okay. TD1, H1. There we go, yeah, so we've got the first 200 days. Looks like some funny things in here, so perhaps there are gaps that we can't observe at the moment, so that will be the next thing that we need to do, is check to see if there are any gaps. In other words, are there any nans, N-A-Ns? So nans, let's check for nans. So we type in nans is equal to find. So we want to find if there are any nans. IsNan is a function that returns a positive index if there are any. Okay, so what we want to do is find out if this is empty or not. Okay, so if we have any notter numbers and nans in there, then this variable nans should be empty. But if I look at my workspace over here, it clearly isn't. Okay, so I've got my nans here in my workspace, and it is not empty. So there are clearly positions within our time series where there is no tidal height information. Okay, and therefore we're going to need to fill in the gaps with something sensible. And we need to do that by, well, one of the easiest ways to do that is by comparing that gap with the two neighbouring points. And very often what you do is to fit a function between the neighbouring points and find out what your missing data point would be predicted as. And this is called interpolating. So we interpolate by comparison with the nearest neighbours. So we actually need to write a function to fill in those gaps. So let's start a function called fillGaps.m. Oh no, there's already one that exists. Okay, well let's not call it fillGaps. let's call it edit find and fill gaps, maybe. Okay, you can call it what you like. It's a bit wordy for my liking, but never mind. Does not exist. Yes, I do want to create it. Okay, so let's then type up our function. We want it to output a new time series, so a new y variable, so let's call this y new with no gaps in it. We want to pass it, so find and fill gaps. We want to pass it our original time series, or original time axis, sorry, and also the old y-axis, or the old tidal height. Okay, and so what this will do is this function will import a time axis and an associated y-axis, okay, which is our tidal height, that has gaps in it. And it will find any gaps in y old, fill them in with something sensible. So we'll interpolate those gaps, and it will output a new tidal height or new y-axis that corresponds to each time index. Okay, so let's write out what this does. So given a regularly sampled time series with nans in it, with nans, i.e. it has gaps, this function will find and fill in the gaps by, let's do linear interpolation. So otherwise it will draw a line between neighbouring points. So between neighbouring points, and then we'll plot it to check. Okay, so first of all we've got to find out what the good data is in order to interpolate between those that do not have any data at all, or ones that have nans. So what we want to do is find the indices that do have numbers. So find the indices in y old that have real numbers, i.e. not nans. Not nans. Okay, so to find those indices, let's call them indices of not nans. And we want to find those within, and so in order to negate something, or to say it's not something, we use a little tilde, which you might have come across before. So we want to find something that is not a nan. Okay, so isNan finds the indices that are NaNs, and not isNan finds the indices that are not nans. In other words, it finds the indices that are real numbers. Okay, so we want to find those within our old time series. So it's finding all the good data in our old time series. Okay, and now we want to assign a time series to go with that, so a time axis. Assign our okay, so we don't need a semicolon. Okay, so let's have a time series indices with, using those indices. So we want to use our previous time series and import those which have these indices. So in other words, all the numbers that are real in our original time series, we also need to find out what the times are associated with that. Okay, and so we're going to call all of these basically our time series, which is real data. So the indices of not nouns, not NaN. And then we need to do the same thing with our tidal height. We need all the tidal height data, which is real. So that's Y old. And in fact, because we're using Y's within the function, so we don't get muddled up, let's call that Y, not nan. Okay. So the T not nan and Y not nan are good data. So this is not a regularly spaced time series, and there are gaps. There are no gaps in the data, sorry, but it's irregularly sampled. So now we want to interpolate at the original sample rate, which was given by TD1, which is what we will import up here. Okay. So now we want to interpolate at the original regular sample rate, which was given by original time axis. Okay, so to interpolate that, we can use a function called interp1. So if I just go back to the command window again, let me just shift that over to the side for a second. If we type in help interp1, okay, so interp1 is one-dimensional to interpolation. Okay, so it takes in x, v, and xq. So x here tells you what these input variables are. X is a vector. Okay, so in our case here, it represents our x-axis, which is our time axis. V, we're going to use it as a vector because it has the same length as x. And our xq, where's that? No, it's not jumping out at me. Oh, these are the query points. Sorry, right up the front. Okay, so in other words, it's going to find VQ at these points XQ, which don't exist within X. Okay, so in other words, this is the time series that we want. In other words, original time axis. These are the output tidal heights that we're looking for, and this is the good data, but that's not regularly sampled. Okay, so X is our irregularly sampled data that we've just generated, the ones that have real data that doesn't include any of the NANs. Okay, so if we go back to our function here again, we would type in, so we use the same format here where we're inputting the irregular time series, i.e. the T naught nan and the Y naught nan, and we want it to query or interpret what the values are at our original time series. So in other words, that will be what we're passing to it, which is T. So this is the time series we really want, T. Okay, and then we can just plot that up to check that it works. Let's do two plots, one with the old and one with the new. Okay, so we do subplot 2, 1, 1, plot T, comma, Y old, and let's just label it so we know what it's called, data with gaps, and then we'll do another one underneath it of the interpolated time series just to check they look the same. Really, that's all we're looking for really. So T with Y new. And so that is our interpolated data. Okay, so that should, I just checked that it saved it in the right place. Oh no, it has, it's fine. Okay. Might as well replace. Okay, so we should be able to call that now from our command window. So let's just note the syntax up here again. So find and fill gaps, we need to pass it our time axis and our current tidal height data with the gaps in it. Okay, so if we go back here and remind ourselves that we've now assigned our time as TD1 and our tidal height as H1, because this is the first 200 days worth of data with gaps in it. So let's create our new tidal height then by calling the new function. So H1 new is equal to find and fill gaps, and we want to pass it the time series that we want, the regular sampled time axis, and we want to pass it our first 200 data points of the original tidal height data. Okay, and we have a figure pop up, and you can see at the top plot is the data with supposedly with the gaps, but you might remember that it's difficult to see them, isn't it? But if we expand it out a little bit, then it looks like there's a couple of funny things going on here. You can't see the individual points very easily at all because it's sampled 96 times per day. Okay, we're looking at 200 days worth, so it's a lot of data points there. but you can see that the interpolated data looks, for all intents and purposes, exactly the same. So it really is just a check to make sure we're on the right track and it hasn't done anything really odd. Okay, sometimes if you have bigger gaps within data, then you'll get some very strange kind of straight lines or spikes in odd places. So it's always worth having just that little check to make sure that the time series that's been output at least looks correct. Okay, and if we want, we can also just check that there are no gaps in that new time series. So let's just, as a test, so test, let's just find out if there are any nans. Find is nan in H1 new. And we look in our workspace here and we can see that this test is empty. So then that variable tst, which was finding the indices of all the nans in our new time series, indicates there are no gaps or no nans. So excellent. We can proceed.